This is now very, very important for any programming language. Now, yesterday, we have put down some note over here about the data types. We are going to look into that. I will copy that one directly over here, this one. Okay. Let's put down this one over. So Python has two types of data types. One is called as fundamental data type. Second one is called as sequential data type. Now, fundamental data types means you should remember that under this, the integer will be coming, float will be coming, complex will be coming, boolean will be coming, and string will be coming. Now, we are going to look deeply into this. Okay. Now, what is the properties of the fundamental data type? The properties of the fundamental data type is, fundamental data types are immutable. That means they cannot, the value inside the memory, we can't change it. That is, we can't change it in a simple nutshell manner, like we can't change the value inside the same memory. That is what exactly mean by the immutable. Now, second important thing is the variables holding the same value will be pointing out to the same memory location. Because of these important properties like immutable and variables holding the same value point out to the same memory locations, because of this memory sharing concept and the immutability concept, the Python saves a lot of space for the, for storing or processing the data, and it will, process the data very, very fast. Okay. Now, again, don't think that if we are getting if the file is there, when the file comes out of the Python, that file itself is with the low memory. No, once the data is taken into the Python program will be there like this. Remember this, don't get confused over here. See the Python, where the Python will be there, guys. We install the Python, and over the Python, we will have the PyCharm over here, right? PyCharm. Now, when you are getting the data into the PyCharm, okay, when you are having a data, your data is over here. Just take it. This data is maybe around 1 GB data is there, 1 GB. Now, in this, like all our characters are there. All our characters, either it can be a uppercase or lowercase, all our characters. That is A to Z or capital A to Z is there over here. Now, so when you take it to the processing over here, even though it is a 1 GB data, when you take it into the processing purpose, this all of the data will be arranged in such a way that, using our memory sharing concept, that is all the repeated values will be pointing out to the variables holding the repeated value will be pointing out to the same memory location. Because of that, it will occupy only 52 bytes. Now I will show this one very clearly while dealing with the strings. I will explain you very detailedly when you go with the strings. Okay, this is a very, very important one. The same thing if I do it with the other programming language, like I'm doing with the C++ or Java or anything like that, C++. So what will happen? The data will be there. This data, we are going to get into, now this is 1 GB. 1 GB data is there. This 1 GB data, when I give it to my C++, here also, while processing, it will occupy 1 GB only. Now 1 GB. Now obviously here 52 GB, 52 KB, kilobytes I will take it, or 52 bytes only we will take. Bytes. 52 bytes, where is 52 bytes and where is 1 GB? So which one will be faster? This one will be faster. Now why this is possible? Because of the two major concepts. Why? One is immutability, second one is the memory sharing concept. Okay, now let's go deep into our fundamental data types and we will see much more detailedly into this. Now, what is a sequential data type? We have already seen the sequential data type. Now we are going to check into that over here. Okay, sequential data type. Now, sequential data type is nothing but first thing is sequential data type holds the multiple values. Just remember this, guys. The next all will be following itself. When there are multiple values are there under one variable, how it will show? It will be holding a series of internal memory will be occupied. That's what it is. Multiple values are stored in a series of internal memory. Once the memory location is occupied series, how to identify? Using the indexing. Okay, using the indexing. So just remember this point, that is enough. Okay, automatically you will get this one. Okay, now a lot of times they will be asking in the question about this, what is the difference between a sequential or this sequential data type? Sometimes we will call it as collections data type, or they are called as compound data type. All these things will be coming into this. Okay, all these things will be coming into this. Okay, this is what is called as actually what we call it as, sequential data. Now let's see about that. Now we will go this one, but we will enter into the sequential later part, or maybe after a week or so we will be into this one. Now till then we are going to talk about fundamental data. Okay, now let's deal with it, guys, one after the other. So let's talk about the integer. What is an integer? See, an integer is nothing but int is a data type which represents the integer number. Over here, actually, it will be an int data type. Integer is a data type which represents the integer number. Now, what is an integer number? Now, integer number is nothing but, I'll write it over here. Integer number means integer. Let me put it as directly integer. Integer can be a positive number. It can be a positive number or a negative number. Okay, a positive number or a negative number, or including the zero. Zero can also be considered. That is, almost all the numbers will be coming under the integer without any decimal point. And it can be a positive number or a negative number or a zero also without any decimal point. Let's talk about some examples on this. So I have a number like 442 or 443. Is this an integer? Yes. Now let's take it a one more number, minus 65. Is this an integer? Of course, yes. And there is a zero is there. Is this an integer? Yes. And if you have it something like this, a bigger number, yes. Even this is also an integer. All this comes under the integer. Okay. Now in Python, this integer will be represented in the short form as int, small case int. So in Python, the integer is represented as int. So it is a short form of the int. Okay. Now, if you want to convert any number to the integer, just take it, you want to convert a number into the integer. If you want to convert any number into integer, we are having a function called as int function. This is an int function. Now, what does this do? It will convert any other form into integer. That is the purpose of the int. Now, don't expect that each and every value will be converted. No, not each and every value. Some data types can be converted into integer. Some cannot be converted into integer. Okay, that is what it is. So this is how it is represented. integer is represented as int. As int. Int. An int function is used to convert any value to integer. Not all the values, only some values will be converted, but I'm giving it any value to the integer. Now, integer has a different forms. Okay, integer has different forms. What are those different forms are called as? One is a decimal form. Forms of integer are writing forms of integer. First one is called as decimal form. Second one is called as binary form. Third one is called as octal form. And fourth one is called as hexadecimal form. Okay, hexadecimal form. Okay, first one is called as the decimal form. Second one is a binary form. Third one is a octal form and hexadecimal form. Now let's talk about each and every form over here. This will be, maybe sometimes they will be asking about in the interview, but some of the forms we will be using in the future. The binary form we will be using very frequently in the future, because there is a bitwise operator is there where everything has to be converted into binary form. And octal form, during the research work, this is used a lot, octal and hexadecimal. Okay, now let's see that what is actually they are. So if you talk about a binary, a decimal form is a very general form which is used, any numbering system what is used around the world is called as a decimal form only. Now, for example, if you take it like, what is the, if I ask you, how much, what is the distance between like maybe India and US, or India and Hyderabad and Delhi? Now, when we say that 3,000 or 9,000 or 6,000 or 3,000, whatever you are saying, that is called as a decimal form. Whenever you are using a number system in a general format, so that is called as a decimal form. Now, if you take the currency also, now how many dollars you have? You will say that I have $100. How many rupees I have it? Maybe I say that 2,000 rupees I have it. Okay. Now this numbering, when we say 100, 10, 92, 93, 102, like 1020 or 2040, whatever the numbering you are using, this comes under the decimal form. Okay, guys, this comes under the decimal form. So now the decimal form is nothing but a default form whenever in any programming language. Okay, so whenever you are using, okay, whenever you are using a number in programming or in your life, in real life, or for a transaction, for measuring a distance or counting something, this is nothing but a decimal form only. Okay, so decimal form is a default form of the integer or any number system. This is the default form of any number system which is used, okay, in the program also and out of the this also. Now the base of the, how to know this one is, the base of this decimal form is 10. 10 is the base of this. That is, the decimal form has the 10 digits to represent the decimal form. 10 different digits are there to represent the any value you take it in the decimal form. That is a combination of these 10 digits. That's why we call it as the base numbers are 10. Base numbers are 10 with which we can combine and we will show any decimal form. Now, what are those? The base numbers are numbers which are used in decimal form is 0 to 9. 0 to 9. If you take it 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the 10 digits which are used to represent any number. If you take it like whatever may be the number, in billions, in trillions, or in thousands, in lakhs, in crores, whatever you take the number, that will be used between, or that number is shown to you or represented to you or presented to you by using the combination of 0 to 1. You try it out, that is the one. This is what is called. And this is what is called as decimal form. Decimal form is a default form, and it is having a base 10, and the numbers which are used inside this is 0 to 9. And the example of this decimal form is any number you take it 863. This is the number, or you take it as 923, or you can take it as like 100, 1, 2, 4. All these things comes under the decimal form only. Okay, decimal form only. This is all called. And whenever you print anything in the Python, whenever you print a number in the Python, any form you print it, by default, it will print in the decimal form. Okay, remember that. Whenever we use the print function to print number of any form, by default, it will convert it into decimal and it will print it. Okay, so default is print by default, it will print the value any number in the decimal form. Print function by default, it displays any form of number in decimal. By default, it will do this. Okay, now we are going to see this. Not to worry about, we are going to see this. This is about the decimal form. Now let's talk about the binary form. Now you must have heard about the binary form, like so many times about this. The binary form is nothing but a form which it's a numbering system or numbering form in which we use 0 or 1 to represent anything. Okay, if you want to represent anything, we are going to use the 0 and 1 over here. Okay, we use the 0 and 1 over here to represent anything. So this is the binary form is a form where the number, any number is represented with the 0 and 1. Okay. Zero and 1. Okay, 0 and 1 combination. Now the second one is, what is the base of the binary form? The base is equals to 2, because the maximum numbers it will use it, the maximum type of numbers it will use it, number of is 0 and 1. So base numbers is only 2. Whatever number you give it, it will represent in the 0 and 1 combination only. Now, example, okay, the numbers which are used. Okay, let's see the numbers. We know that the numbers are nothing but 0 and 1. Okay, the numbers are 0 and 1. 1 second, guys. Okay, it is 0 and 1 is the numbers we are going to use. Now, example. Now, this is, if I give it 1, 0, 0, this is what? You will say that it is 100. Right? How you said the 100? The 100 is nothing but a decimal form. The same way, our interpreter also, if I give it like 1101, something like this, the interpreter also understands this one as a decimal number only, like 100. and this one is 1101. That is what it is showing us, right? So the interpreter also understands this as a decimal number only. It is not identified as a, like a binary number. Now, in order to identify this one as a binary number, we have to give a prefix. What is that prefix? 0, 0 and B, 0B combination. That is 0B or 0 and capital B. Anything we can use. So prefix, we use it to represent the binary format is 0. This 0, guys, not O. 0B or 0 capital B. This is the one we are going to use it. Now examples is, now this one we will give it as 0B and or 0 capital B. Okay, 0 capital. Now in this form, like this is the form we will be using. If I want to convert anything into binary form, okay, if I want to convert anything into binary form, then we are having a function called as bin. Okay, bin is a function which is used to convert any form to binary form. Okay, binary form. But remember that. So it is a subform of integer. Okay, remember, always keep in mind that this is a subform of the integer. We are going to see this one after the other. We are going to get into the programming and we are going to see each and every one over here. Now let's talk about the octal form, guys. What is an octal form? So octal form is, it is in this form, any number is represented using it is any number will be represented using the numbers between 0 and 7. Okay, 0 to 7. So in this form, any number is represented by using, okay, 0 to 7. 0 to 7. These digits are combined in this. Okay, these digits are combined to represent the octal form. Now, as you can see this, what is the base numbers? How many numbers you use it to represent? What are the core base numbers? So the base is nothing but 8. Octal stands for 8. If you count it from 0, 1, 2, 3, 4, 5, 6, 7. So how many are there? 8 numbers are there. That is what it is. Now here, the numbers which are used over here is, we will say it 0, 1, 2, 3, 4, 5, 6, and 7. Now in this, if a number is used above 7, then it is not considered as an octal form. Remember that. It is not considered as an octal form. The number should be with the combination of 0, 1, 2, 3, 4, 5, 6, 7. Only these numbers you have to use it to combine them. Okay. Now, what is the example of this one, or how it is recognized? Now, again, an example, if I give it example, I will say that now 621. Now, what is this? It is a 621. Is this an octal form? Yes, it is having the 6. 2 is also there and 1 is also there. But this is a 621, means it is nothing but it is representing the decimal form. Okay, it is representing the decimal form. And to make our interpreter, the same thing happens with the interpreter. Interpreter will recognize this as a decimal form by default. To make our interpreter understand that this is an octal form, then what we will do it is, we are going to give a prefix over here, that is 0 O combination. Prefix is equals to 0 and O combination. This is O combination. or 0 capital O. That is a okay. Now let me show you this. Guys, there may be some disturbance because there are some crackers are going on over here. Sorry for that. Now, now example is equals to this will be the one. O, or I will give it as 0 and capital O. We can use the another number 7, 2, 3, something. This is also an octal. These are the octal. And if you want to convert anything into octal form, then it is called as, if anything I want to convert into octal form, we will use it as oct function. There is an oct function is there. Is oct function is used to convert any form to octal form. Any form to octal form, we are going to use the oct function. Okay. Now there is something called as okay, hexadecimal form. Now hexadecimal form is, in this form, any number is represented between, like actually the base of the hexadecimal form is equals to 16. 16. So now how it will work, how they are, which numbers are used to represent. So numbers which are used to represent over here is 0 to 9. 0 to 9, how many it is? 10. And 11th one is A, B, C, D, E, and F. Now, if you check it out from here to here, we have 10. Okay, 11, 12, 13, 14, 15, 16. So we got the 16 over here. So this is again the prefix which is used. Now you know that why we are using the prefix. Prefix is equals to 0 and X or 0 and capital X. Okay. Now example of this one is 0 X. We can give it as, you know, any number you give it over here. This is an hexadecimal. 0 and X. You can also give it as FACE, face also we can give it. Face. Face also it is at a particular number. Now FAC is now small case or uppercase, anything is fine. That is represented in the same way. Now quickly we will go through this and we will see this one, guys. Now I will show you how it will work over here. Okay, let me open